Hi viewers, welcome to LMS Solution. Today we are going to see about power management of solar PV battery and supercapacitor in DC Microgrid. So this is a Simulink model developed for a DC Microgrid. It consists of a solar PV system, battery energy storage and the supercapacitor storage system. And here we have the solar PV panel. The solar PV panel rating is 2000 watts and single panel rating is 250 watts, and then open circuit voltage is 37.3 volt, and then voltage at maximum power point is 30.7. The short circuit current is 8.66 amps, and then current at maximum power point is 8.15 amps. So when you have to see this, when you have to click this plot, right, so you can see the IV and PV characteristics of the consider PV array for different irradiation condition. So here you can see that for 1000 watts per meter square, the maximum power is around 2002 watts, and then voltage is 245.6. So for 800, the maximum power is 1599 watts. For 600, the maximum power is 1197. For 400 watts per meter square, the maximum power is 791.8. So when irradiation change, the peak power of the PV are also going to be changed. So that need to be extracted, okay, by using some control concept or control algorithm. So for that only we are using MPPT concept. So maximum power point tracking concept. This is the solar PV, right? PV array going to be connected to the DC bus. So here this is going to be considered as a DC bus. Okay, the DC bus voltage we are going to maintain here 400 volt. So the PV array going to be connected to the this DC bus via this boost converter, and then this boost converter going to be controlled by means of MPPT algorithm. So here we are using incremental conductance MPPT. So the incremental conductance MPPT receiving two inputs. So one is PV voltage, another one is PV current, and then it going to be generated duty cycle according with the PV voltage and current, and it going to be processed by a PWM generator. The PWM generator will generate the pulse. So this pulse is going to be controlled this boost converter in order to extract the maximum power from the PV array according with the irradiation temperature condition. And here we have the DC load. So here we have DC load around 1000 watts. And here we have bidirectional converter connected with the battery energy storage system. The battery detail is that nominal voltage we are considered as 12 into 20. That means it like 12 volt battery, 20 12 volt battery connected in series. And the rated capacity of the battery we are considered as 48 Ah. The initial state of charge of the battery is 50%. And then going to be connected to the DC bus. Okay. So via this bidirectional converter, and then here we have supercapacitor. The supercapacitor rated capacitance is 99.5 farad, and then rated voltage considered as 300 volt. The initial voltage of the supercapacitor here is 295 volt. Okay, so this supercapacitor also connected to the DC bus via this bidirectional converter. So we have to create some control logic for battery bidirectional converter and supercapacitor bidirectional converter. So here we have to use that mean double loop concept. That mean we have to measure the DC bus voltage, and then this DC bus voltage is going to be compared with the reference voltage. Reference voltage here is 400 volt. Okay, and then it going to be that mean both are compared here. That mean you have to compare the reference voltage with the actual DC bus voltage, and then going to be processed by PA controller. So this PA controller going to be considered as a voltage controller, and it will be generate the reference current. Okay, so reference current for that means reference current for the battery bidirectional converter, and then it going to be processed by a filter. And then here we that means after filter we are having some current, right? That current going to be compared with the current of the before filter, right? So this will be act as here the reference current for the two supercapacitor bidirectional converter. Okay. So here you have to compare that this current with the battery current, and then this current with the supercapacitor current, and then it's going to be processed by a PA controller. So this PA controller going to act as a current controller. So this controller will be generated duty cycle. Okay. So this duty cycle going to be processed by a PWM generator. So the PWM generator will be generate the pulse. Okay. So this pulse going to be used for control this pulse is used for controlling this bidirectional converter of the IGBT of this bidirectional converter, and this pulse going to be control the IGBT of this bidirectional converter in order to share the current according with the PV power and load condition. So this is a model of that DC microgrid consists of solar PV battery and supercapacitor. So next you have to analyze the simulation result. So here we created the irradiation variation. That means here you can see that irradiation will be varied 1800, 500, 300 and 100 for every 1 second. Okay, every 1 second, and then you have to see the response of the PV voltage, current and power, and then battery voltage and current, supercapacitor voltage and current, and then you have to see about the DC bus voltage, current and power. Okay, so already we simulate this model. Here I am going to explain the simulation result. So this is a PV voltage, right? The PV voltage is here. You can see that this is almost maintained around 245 or 250 volts, right? And then here you can see that this is a PV current for 1000 watts per meter square. The PV current maintained at 8 amps, and then here you can see that for 800 it going to be maintained around 6.2 amps. For 500 it will be maintained at 4 amps. For 300 it will be maintained at 2.2 amps. For 100 watts per meter square it will be maintained around 1 amps. Okay. And then you can see that the PV power rate for 1000 watts per meter square, the PV power maintained at 2000 watts. And then you can see here that for 800 watts per meter square, the PV power maintained around 1600. For 500 watts per meter square, the PV power maintained at 1000. And then here you can see that for 300, the PV power maintained around 350 watts. And then here you can see for 100 watts per meter square, the PV power maintained at around 100, right? So here you can see the power will be vary here, and then here you can see the DC load, DC bus voltage is maintained around 400 volt, and then this is a DC bus, that means DC load current and DC load power. So the DC load current, right, is maintained around 2.5 amps, and then DC load power maintained around 1000 watts. Okay, but we have to see the variation of battery detail and supercapacitor detail during variation of PV power, right? When you have to see that from 0 to 2 seconds, right? From 0 to 2 seconds, the PV power, right, is in between it is more than 1000 watts, right? So from 0 to 1, the PV power is 2000 watts. From 1 to 2, the PV power is around 1600. So that means here load is 1000, and then PV power having more than 1000, that means it having excess power. So because of that, what happened, you can see that battery power and battery current and supercapacitor power and supercapacitor current, right? So here you can see that it is in negative, right? And then here also you can see that it is in power is in negative, and also you can see that the supercapacitor current is in negative, and then supercapacitor power is in negative. So what's the meaning? That means the PV power is greater than PV load, so that's why battery and the supercapacitor charging mode. Okay, so that's why the current is negative. So the battery current and the supercapacitor current is negative, and then battery power and the supercapacitor power is negative. That what's the meaning? That both are in a charging mode. So here you can see that this is voltage of the battery, this is voltage of the supercapacitor. Okay. So next you have to see that when the PV power, right, comes to 1000 watts, right? So here you can see that comes to 1000 watts. What happened? now that condition is right, that means PV power which is equal to load power. So that's why you can see that here you can see that the battery current goes to some positive value, right? So battery will supply some power, right, to the DC microgrid, and then you can see the supercapacitor current is equal to 0. Okay, so now what happened, PV power which is equal to load power, so that's why battery comes to discharging mode and supercapacitor comes to ideal case. Okay, so when you have to consider from 3 to 5 seconds, when at the time of 3 seconds you can see that the power change from 1000 to around nearly 500, right? 500. So now you can see that because of the reduction in the power, that means now the power of PV is less than load power. So that's why the battery supplying some power, right? And then battery current, you can see that it comes to positive. So positive means battery in a discharging mode. And also during changing of PV power, that means reduction of PV power, what happened? The supercapacitor, right? Supercapacitor aiding some power during some short time. So here you can say when you examine this one, you can see the variation, right? So when change in reduction in the PV power, right, the supercapacitor will be provide some power during that transient of that reduction of power PV power from 1000 to around 500, right? So the supercapacitor will be aiding during that change in power in the PV, that means reduction in the power in the PV. Remaining time is comes to 0, right? Remaining time it will be maintained around 0 only. The remaining power, right? For example, the load power is 1000 and here is we are having around 500. The remaining power will be supplied from the battery. Okay, and also you can see that at the time of 4 second, again the PV power is reduced because of the reducing irradiation from 300 to 100 watts per meter square, right? What happened? The battery power again increasing, and also you can see that the supercapacitor now aiding some power during that change in irradiation condition from 300 to 100 watts per meter square. So in order to support that the battery. Okay, and then after that, after some time, right, you can see that this comes to 0, right? That means the supercapacitor going being work when that PV power goes less than load power. During that time battery will supply the remaining power, and also the supercapacitor will be supplied during that the change in irradiation condition. That means reduction in the radiation from 500 to 300, 300 to 100. Okay, so this is a working of this model. That means the how that power is going to be managed according to the load condition and irradiation condition. So this is a working of this power management of solar PV battery and supercapacitor in DC microgrid. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.